So everything in this class is cumulative, meaning my midterm will not cover just the material between the last midterm and now. If I did, that would be a short test. So I'll try to focus on more recent stuff to the extent that that's possible. Please know how to correctly answer all the questions on midterm 1. I am not above asking the exact same question again. Why do I do that? 1, I'm lazy. 2, I'll usually pick the questions that people missed a lot. 3, I want to develop a reputation for asking questions I've asked before. Why do I want this reputation? Because if you believe that I'm going to ask questions I've asked before, then after you take a test, what are you going to do? Yeah, exactly. And I don't like judging you. I don't think that's the point of a test. I think the point of a test is to create a learning experience. That's so cheesy. It's the stick that we use to make you learn, right? That's kind of what it is. And so if you have to go back and figure out what you did wrong, then that's good. So therefore, you should expect me to be somewhat repetitive, but of course I'll vary it a little bit so that you can't just memorize the answers. You have to actually think about the question or something like that. But for that reason, it's also a good idea to review past midterms, and presumably my testing style hasn't changed much, especially since last year, so the most recent one's probably pretty close. As it happens, I did my review of the last midterm last year, and I left the answers on it, so there's a test even with the answers. Let's see if 2016 has answers. No answers on 2016. 2015, no answers. So, okay, you'll have to do a little work to study from the older tests, but at least you've got answers on one of them. And you can also look at them and see how much overlap there is between my midterms, and that'll give you an idea of how much overlap to expect with the next midterm, right? Yes. So every year I change my plan a little bit. And so, for example, first year I taught this class, I had covered HTTP, and I asked questions about POST and HTML and that kind of stuff, and we just haven't even gotten there yet. So you're pretty safe. Although today, if I have a little time after this review, I'm going to start covering HTML and a little JavaScript. If you see a question that just doesn't even feel like we've covered it or has anything to do with this class, just skip it. It won't be on your midterm. It was just, that's what I covered that year. Well, okay. Please know how to automate builds with shell scripting. That's something we've definitely covered, but I haven't really tested it, so maybe I will. There are some of you that are just doing Java C star.java. I would like you to know how to write a batch file and make those work. Please know everything that was on midterm 1 review. Why? Because everything in my class is cumulative. The reason I do that is if you can retain something in your head from the night before when you study to the test, so what? That's worthless to you, right? If you have to retain it for a whole 2 weeks of time, maybe some portion of it will stick in your head long after the class, and you'll actually retain something and benefit you. So yeah, I know that's more cruel, but I like cumulative. I think you should actually have to learn stuff in school. Especially, please know what you did in all of the assignments. Because I emphasized this last time, but I just want to state again, if you've completed the assignments, you're expected to have understood what you did. And if you don't, I will try to get you. And please know model view controller architecture, because we've been doing that all semester. And there's not much to know there. You just know what the different, if you don't know what the different components do, then obviously you haven't been paying attention. You should know how to debug pretty much anything at this point. I think the last assignment, the deep copy recursion AI one, if that hasn't made you debug something, wow, you're just good. And that's cool if you're that good. Maybe you'll never need to debug anything in your entire life, although I doubt that has ever happened once to any programmer ever. So if that's the case, then it's my fault for giving you too small of assignments, and I deeply apologize, but I'm not going to ratchet them up in difficulty at this point. I hope you've spent some time with the debugger. You better have been looking through the call stack and clicking on the different stack frames and looking at the watch variables and know about step over, step in, step out. If you've not done that, you've missed something really important. And maybe I won't be able to test it because you won't have a computer or a debugger on the test, but please get acquainted with your debugger. Learn how to systematically find a bug without using the bleeding eyeballs debugging approach. Because if you don't get that out of this class, I have failed you. And I don't want to fail you. I want you all to leave this class saying, Dr. Gashler made me a programmer. So thankful to him for the rest of my life, that kind of thing. So please spend time with your debugger. All right. Know how to write a video game. Only reason I say that is because we wrote a video game. That's kind of what we did, so you better know what they are. Yeah. If you don't know what a call stack is about or for, or you don't understand that the variables in the watch window come from the debugger following from the stack into the heap, or if you don't understand that member variables are inside the objects that are on the heap, or if you don't get the big picture, the theme of what's going on in your machine, then you cannot debug. So I feel like maybe I could test your debugging skills by trying to probe into questions that figure out, do you get object-oriented programming? Do you know the difference between static variables and member variables, static methods and member methods? Where would the this variable be? Is it on the stack or the heap? Is it inside the object? Are member variables inside the object or on the stack? How does garbage collector work? Stuff like that. I think that's highly correlated with can you debug, because you either get the whole picture or you don't. And ultimately, the grand secret to debugging is this. You have to understand what's going on and what you want and what it's supposed to happen, right? You have to understand what your program is supposed to do. Then you step through and see how what it actually does differs from what it's supposed to do. And wherever they first deviate, there's the bug. Does that make sense? I mean, that is debugging in a nutshell. You can debug anything with that high-level approach. It just comes down to, do you know enough that you can turn that high-level approach into an actual action? Or do you become crippled and suddenly just say, there's a bug, what do I do? What do I do? I hope you can say, oh, there's a bug. Think for a minute and then say, aha, I know how I can figure out where the actual behavior differs from the expected behavior. And when you figure that out, you are debugging. So that's my philosophy on debugging. Get it? Okay. The tools the debugger provides, step over, step in, step out, breakpoints, continue, call stack, variable, watch window, those types of things are tools you need to be familiar with and know what they do and know how to use them. But using those, you can answer the question, how does expected behavior deviate from actual behavior? And that right there is your entire domain, your field of employment or whatever it is. If you can do that, you're worth $80,000 a year or whatever they pay programmers these days. Because most people can't do that. It's hard to debug stuff. It actually requires straining your brain to understand your code, and code is hard because it's not even written in English, right? But you're starting to look at code and thinking, hey, that makes sense, right? I hope you are, because if you are, you don't just speak English anymore. You look at code and you say, oh yeah, that's totally clear. And if code is clear, you can do anything. Just give you some time and Google and not a lot of pressure. It's really hard to code under pressure, by the way. And you've all experienced that. And I'm sorry, I'd take away the pressure if I could, but I don't know how. I'm rambling. Understand how to prevent race what? We haven't even covered that. Dang it. That one won't be on your test. I totally have to do that lecture sometime soon. Man, stuff's piling up and I keep going back to cover my previous stuff better. I have this conundrum. Do I teach new stuff so you've covered everything, or do I teach a few things really well? I think teaching a few things well is the better approach, but yeah. Sorry, this is on the review, but it won't be on your test because I haven't covered concurrency and I'm not going to get to it today. But you better know recursion. I didn't really teach recursion, but you better know it anyway, because now we've used it and assignment, the last assignment was all about it, and so I'll ask some recursion questions. They won't be, please write an AI in the space provided. That would be stupid. But I could ask questions like, please use recursion to write a function that counts from 2 to 15 by 2s. That's impossible. 2 to 16 by 2s. Or something like that. And you should be able to accomplish that task using recursion if needed to. Or something like that. Those are kind of the high-level stuff. Those are stuff. Stuff is singular, isn't it? That is the high-level stuff. Stuff. That's a bad word to use. Anyway, OOP. What does OOP stand for? Yeah, you better the heck know what that is at this point. This is kind of the world's most important paradigm in computer programming. And this class is called Programming Paradigms, right? Therefore, object-oriented programming is programming with objects. Java is kind of the object-oriented programming language. There's the canonical object-oriented programming language after that one with the mouse. What's it called? Smalltalk. Smalltalk used to be, but, well, it didn't used to be. Never mind. Scratch that. Polymorphism is an object-oriented programming concept that you should understand really well. And you should know what abstraction is, and an interface is basically a class with abstract methods. And you should know about vtables and collections and iterators and casting. You better know what types are and how to write deep copy. Any questions on any of that? It's totally okay to just ask questions like, what's object-oriented programming? No, that one's not okay. But it's okay to ask questions that seem ignorant because that's what a test review is. Yes. vtables. So this we didn't do much with. In fact, we never will. And I'm not even 100% sure Java really uses them technically. A vtable is an internal thing. It's how the language implements polymorphism. The idea of a vtable is this. Somewhere inside is a, well, in Java, think about it this way. You have a class. For every object, there is a class object. The class object is where the static members go. Also associated with the class object is this table that maps to all of the methods for that class. So for example, the vtable of the sprite class has a update and a draw method in the vtable. And when you call update or draw, what actually happens is it takes the object you use to call it, because you have to call tube.draw, mario.update, things like that. It's going to use that object and go to its class object, find the vtable, and the vtable is going to tell it where update or draw is for that type. Now, I really don't know how to test that except for ask questions about it. The gist of vtables is if there's something going on in your head that makes sense, then you probably get it. This is a do you know what's going on under the hood type question. So if we say polymorphism, I don't want you to think polymorphism is this black magic thing where it just automatically knows to call the right method. I want you to think in your head, inside of this language, there's a table. And that table does a quick lookup based on the object. And the object lookup in the table tells it which method to call. And that's how it knows whether to call Mario's update or Tube's update or Fireball's update or whatever update is. Basically, vtables are the secret to polymorphism's implementation. Now, if you wanted to go write your own programming language, just having that idea should be enough that you could basically go kludge it together and make it work. Because you get, oh, I need to make a table. And then you'd go find some data structure to make a table. And you'd make a table. And you could basically implement a object-oriented polymorphic programming language if you wanted to, in theory. It would take you a long time, but you could probably pull it off. I know this because I took a class like this long ago, and I decided to give it a try. I went and wrote a programming language. It sucked. It was a terrible, horrible, awful programming language, but I learned so much. Seriously, give yourself tasks like that. Just go do crazy stuff, things that sound hard or impossible, and you will become amazing programmers. About 2 people in this class are going to go do it now, but you 2 are awesome. Just want to say that. I'm really patting myself on the back because I did it. Okay. Collections generators, we already covered that. Yeah, any other questions? Yes. That sounded correct to me. Let me just restate it again and see if I'm saying the same thing. Whenever you make a polymorphic call, meaning you're going to use an object and call a method, but there's a whole bunch of possible types that implement that same method. How does it find the method? Well, it queries the vtable. The vtable maps from the type to the method.